So, hello guys. So today's LeetCode problem is find all possible recipes from a given supplies. So what is the problem? Saying that you have a information about the n different recipes. You are given a string array recipes, okay, and the given a 2D string array ingredients. The ith recipe has name recipe I, and you can create it if you have all needed ingredients from the ingredients of I. So for example, if you want to make this recipe bread, you should know or you should have all the ingredients that is present at the same index in the ingredients array. This is what they have given us as an input. Make sense? Recipe I also can be the ingredient for other recipes. For example, if you have the bread, if you want to make a sandwich, you may need a bread in a future. That is ingredient for I may contain a string that is in the recipes as well. Okay, this is what they have given. You are also given a string array supplies containing all the ingredients that you have initially. Means we have something initially to start with, because if you want to make the recipe I, you should have something, right? For example, if you want to for bread, you should have at least the yeast and flour to start with the making the recipes. That is what the supplies tells you, and you have the infinite supply of them. So we have the infinite supply of them, so we can use it infinite times for all the recipes present in the given recipe array. So what they have asked us, they have asked us to return list of all recipes that you can create. You may return answer in any order, that doesn't matter. No two recipe may contain each other in their ingredients. That is what they have given. For example, let's understand this. So for example, they have given us as the recipe bread. So in order to make recipe bread, okay, in order to make a recipe bread, what we need yeast and we need a flour. Then only I can make it. Make sense? So now what is the supplies given us to us? So initially I have yeast, initially I have the flour. So you know, right, for bread you need yeast and flour, and you have already, so you can make it. That's why the output is a bread only, and only one recipe was given. That's why the output is also the single string. Let's understand with the second test case. What is second test case? For bread. So what I will do, I will try to create a graph for it. So for example, if I want to make a bread, I will just write here what I need. I need ingredients yeast and flour. So I need yeast, I need flour. To make a sandwich, okay, what I need bread and meat, and you can see the bread ingredient, correct? This bread ingredient is already the recipe previously. So to make a sandwich, I need bread and need a meat. To make, okay, only two recipes are given, that's it. Now I will, what is the given to me initially? I have given yeast, flour and meat. So initially I have yeast, flour and meat. Using these ingredients as initially, what I can make? So you can see for bread, to make the bread I just need yeast and flour, which I have already. So we can say that using this I can make a bread, correct? Using this I can make a bread, right? It means that I have bread. Now I have yeast, I have flour and meat. Makes sense? Now for making the sandwich, what do I need? I need bread. Do I have bread? Yes, I do have bread. Do I have meat? Yes, I do have meat. So yeah, I can make a sandwich as well. So my order will be first make a bread, then make a sandwich. Correct? And this is the output for this test case as well. You can see that. Makes sense? So let's understand now again for the third test case, and we will try to build an intuition now. If you see, for making a bread, I have some dependency on the ingredients of I. For making the recipe 2, I have dependency on ingredients of second. If to make recipe third, I have dependency on the ingredients third. Makes sense? So whenever we have such kind of the dependency, for example, I have bread, right? So for making the bread, what do I need? For making the bread, just let me remove this. I need yeast and flour here. Correct? So can I do like this? If I have yeast, correct, and if I have flour, correct, can I go to the bread? Can I visit to the bread? Right? If I have both, I can visit them. Using this, I can go to the bread. So in order to reach the bread, or in order to remove the bread, basically you need yeast and flour. That is what it is showing. Correct? Now for sandwich, what do you need? For sandwich, I need bread and meat. So if you have bread and if you have meat, Can you visit to the sandwich? Correct? I can visit to the sandwich, right? This is what they have said. For in order to make burger, what you have? Sandwich, meat and bread. So I have already the meat, I have already the sandwich. So if I want burger, I will just write here. So from bread I can go to the burger, from meat I can sandwich I can go to the burger, and from meat I can go to the burger. So now tell me, if this is my graph becoming dependency graph, which ingredient is easiest to go first? The ingredients who are having the in degree as a 0. So if I write here the in degree of all the nodes, what is the in degree of this node? This in degree of this node would be, I will just write I equal to 0. Ingredient of this is a 0. In degree of this is a 0. In degree of this is 2. Correct? In degree of this is a 2. And again in degree of this is a 3. So in order to solve this, in order to reach all the nodes, what is the best algorithm comes in mind? That is a topological sort. Kahn's algorithm, we can say it as, right, topological sort. What is topological sort says that? Topological sort says that first pick all nodes having in degree equal to 0. Correct? Then pick all nodes, and then we have to put into the queue. Put in queue. Correct? Pick node from queue one by one and decrement, this is the important part, decrement neighbor in degree -1, because if we are visiting this, I have to make sure that I decrement the in degrees of the neighbors by 1. So for example, bread, I have visited this now this is not a part of the graph, so I will just say now bread should have the in degree equal to 1 only, because only 1 is remaining. Correct? This is the important part. So 1 is written, and at any time if in degree of neighbor is becoming 0, put into queue. Correct? This is what we want. And answer dot add, I would just say answer dot add would be the neighbor, because I have found that now I can make this recipe. So I will just put it into my answer array, and at last I will just return this answer array. This is what I have. Correct? Makes sense? Now let's try to basically understand this with the help of the code, what we have done. Okay, so what I have done here, I have taken, as we said, I have taken the in degree, which will show what is the in degree of any node. Adjacency list, which will show which neighbor I can visit using the given node. So it will be like in degree of, like if I took just this test case, for example, I will just take bread and sandwich case. Okay, what is recipe to us? I will just write here the bread and sandwich. Correct? This is what I have input. What is the ingredients for this? For bread, they have given us the yeast and flour. For sandwich, what was that? For sandwich, we have bread and meat. Bread, meat. Makes sense? And the supplies for that, they have given us yeast, flour and meat. Yeast, flour and meat. So for this, now let's see with the help of the code how it will look when we build the in degree array. I'm using the hash map over here to represent, because as we have the string as a node, and adjacent list, which is again the dictionary of the list, where key is a string and the value is a list. So now what I'm doing, I'm looping over the recipes, and I'm just putting in degree of recipe is equal to the length of ingredients. Okay, ingredients. So recipe, if I go I am iterating over here, and I'm just saying, okay, I will just build here the in degree. Now my in degree will be here, and I will keep my adjacency would be here. So for better understanding, I will put it here. Correct? Now my in degree of braid is length of the ingredient of I, which is the length, that is a 2. So my braid is dependent on a 2 recipes. Makes sense? Now I will come here. What is sandwich? Sandwich means length of this again, length of the ingredients again. So for example, so that's why the sandwich will have again 2. Makes sense? So now this is my in degree looking like this. Correct? And at the same time, what I'm doing for ingredients in ingredient, I'm just putting adjacency of ingredient equal to append recipe. It means that from this I can go to the bread, from this flour I can go to the bread. Same for from bread I can go to sandwich, from mid I can go to the sandwich. This is what I'm just putting over here. So I will just write it. So from east I can go to the bread, from flour I can go to the bread, from bread I can go to the sandwich, and from meat I can go to the sandwich. Okay, this we will need this info. Now what is my queue? In queue I am just putting all the supplies, whatever the supplies they have given us as the initially, that I will keep in a queue. So supplies is here, so I will just take them here. So now my queue, okay, now my queue will have initially will have east, okay, flour and meat. Correct? Now I will pick up the first one, that is the east. I pick up the east, my bad, I will just pick up the east. Now my ingredient is a east. Correct? Makes sense? Now I will check if my this ingredient is present in my adjacency list or not. It means that if it is a present, it means some of the ingredients, some of the recipes are dependent on this east. Makes sense? So yeah, I can say yeah, bread is there. Correct? So what I will do, as I am removing this from the queue, right, I am going to remove from the queue. So I have just removed it because I have taken it out. So whatever the recipes are dependent on east, just decrease their in degree by 1. So east, okay, the bread is dependent on east, so in degree of bread will be from 2, it will become a 1 now. Makes sense? And this ingredient has been removed from the queue now. Now I will go for the next ingredient, that is a flour. Correct? I will just put it here and I will remove this from the queue again. Now my queue has only the meat. I will just write it again. Now my queue has only the meat and I have the flour. Again I will check from for flour which recipe is dependent on a flour. Again a bread, so I will decrement the in degree and by 1 it will become now 0. And as we said, this case, okay, if any time my in degree is becoming 0, I will just append it into the queue. So now my queue will have, okay, my queue will have the bread as well because in degree has become 0. So that's why I will keep it here. And at the same time I will just appending into the output. So if this is my output list or array, now it has a bread here. Make sense? Okay. Now at the next iteration, I will take a meat out of the queue. I will take it out of the queue and this will be removed. And I will check, is there any, yeah, sandwich is dependent. So I will just decrement by in degree of sandwich by 1. So in degree of sandwich is now 1. Okay, in degree of sandwich is now 1. Makes sense? So I will just remove it. I will go here. Again bread, I have taken it out. So now I have the bread out of the queue and queue is now empty. So I have the bread here. Makes sense? And now I will check, is there any dependent recipe? Yeah, sandwich is there. Correct. So I will again decrement the in degree of sandwich by 1. So it will become now from 1 it will become now 0. It was 1, now it becomes 0. At any time it is becoming 0, I will just append it into the queue, right? And I will append into the answer array, sandwich. Makes sense? Now my current ingredient is a sandwich. So I will just put it here. Sandwich, I have the current ingredient. Let's see, is there any neighbor? You can see it is not even in an adjacency list. It means no recipe is dependent on sandwich. So I will just remove it. That's it, done. And you can see whenever my queue is becoming empty, okay, I am just stopping my this loop and I am just returning my output, whatever. And currently my output is containing the bread and sandwich, and this was the output for the second test case. If you see here, bread and sandwich. Correct? So I hope you got this problem, and we solve this problem using the topological sort. So time complexity for this problem would be, first of all, we are building the graph. Okay, we are looping over the all the recipes and the ingredients. So it will be the big O of R plus ingredients, whatever the we are going with. And for the BFS, we will have again the big of R plus I, where I shows no, the I shows the age between each ingredient and recipe age, and the R is the number of recipes that we have, because already we are putting it into the queue. So this will be the time complexity for this, and space complexity would be the basically the space complexity would be the big of R plus I, again the number of recipes that we are putting into the my in degree, and the adjacency list will have the big of I, basically the number of the ingredients that we are putting over there, right? So I hope you got this problem. See you in the next video. Thank you.